Discussing Luca Carlone's presentation recently about spatial intelligence and memory. Has made himself a name for SLAM, simultaneous localization and mapping. And I would say he's a traditional engineer in the sense that he puts together optimization tools to solve problems, and SLAM is a very good example of that. So this is a very compute intensive kind of Frankenstein type approach towards engineering and intelligence. And in this presentation, he actually makes the step towards end-to-end training. So he's trying to involve more data-driven approaches, more understanding of the environment through learning. And what he's, in essence, what the presentation is about is that you can do two things augmenting SLAM. One is you can, so you see the world and then you map the world and you try to memorize the world, so the map, and you give them the map semantic meaning with the help of foundation models. So for example, Grok or GPT could be helpful. So you actually understand that a chair is something you can sit on, and that the door next to the bathroom is a different door than the door next to the living room. Like that kind of semantic understanding is in principle obtainable through end-to-end training, but it will be way too compute intensive, and therefore he suggests that what we do is we learn the environment, we add semantic information, and we filter the actual necessary memory and understanding of the environment based on tasks. So it's task-driven, memory-driven SLAM, something like along those lines. And I think this is an interesting presentation for several reasons. I think first, there's technology being introduced. I don't want to spend too much time on that because for us here at Orange Capital Partners, these traditional engineering methods are always interesting to look at, but we're much more on the other side of the fence, on the sort of bit the lesson side of the fence, where we're trying to, as much as possible, train end to end. And then have, memory is okay, actually. Memory is okay because, like Carl Schwager says, most of what robots do is memorizing anyway. The problem is, of course, what should we memorize? And Luca is offering a solution here where he's saying, well, how about we just memorize what's task specific? And this is where we kind of a little bit disagree, because how do I really know what's necessary for the task?
Okay, so we're going to split this in three sections. Number one, we're going to talk about Carlone's approach. Number two, we're going to question generally, or we're going to discuss the end-to-end versus Carlone. And third, we're going to argue that solving the energy problem is actually a more promising path towards intelligence, and that we shouldn't have priors other than the actual data, as much data as possible, as much general models as possible, and then let the models actually learn by themselves through experience. This is not even a podcast. It's July 2nd, 2026. It's Jim for the year. We're down 3%. The market's up 8%, we're underperforming by 11%. So Carlone has, again, like his approach is, I would say, pretty engineering. Like he comes from a sort of old school engineering background, and I don't mean this in a derogatory way at all. His PhD thesis, for example, nonlinear estimation techniques for autonomous navigation in single multi-robot systems. That's so what he did in his PhD, which then ended up in what generally became SLAM, is trying to find techniques to estimate positioning and mapping for robots, and that's being used in drones, for example. But I think it's generally kind of more of a Frankenstein type approach towards robotics, which of course, when he got his PhD in 2012, that was the way to go. If you think about it, he must have thought about this 5-6 years before. So there was, the data-driven approach, the neural net approach was just not as successful back then as it is today. Now, to be fair, and now let's talk about his proposal here that he's giving at this particular presentation. He is actually offering a more general way to look at at robotics SLAM. Now he doesn't call it SLAM anymore, so let's just call it robotics intelligence. He's talking about spatial intelligence, which of course was a big theme at CVPR. And I think that is sort of the word of 2026, at least when it comes to robotics and vision. So how can we get spatial intelligence to the robot? And the first thing, of course, is now, let's say we start with SLAM and we can do SLAM more data driven, so we don't have the actual estimation techniques and all the nonlinear approximations and all of these things which are very compute intensive and on the edge for a robot, let's say humanoid robot that has to act in real time with humans, that will be too slow. So then how can we improve that? We could have maybe data driven approaches to mapping and localization, and the next step would then be to give those maps a certain semantic foundation, right? So you use something like foundation model, like Grok or GPT, and you give it semantic foundation. And I think we at Orange Capital Partners, we're very bitter lesson driven here. So we absolutely believe that the less priors, the better. Although there are some fundamental priors that we cannot escape, and one of them is what kind of data we train on. The other is what kind of architecture we use. Those are the actual priors we should be thinking about. What kind of hardware we use, what kind of memory. Now, Carlone is not talking about those types of price. He's talking more about the traditional price. So let's say we tell the robot the chair is something you can sit on, and the door next to the bathroom is not the door next to the living room. Like that's what he's trying to do. And I think we're a bit on the fence here because we believe that the less we impact the model with knowledge, the better. But then on the other hand, we have knowledge, and this is something that Laldan Koltun spoke about. Like we have this semantic knowledge that foundation models offer us. Why don't we just use it, right? And I am kind of on the fence here because I feel like, yeah, okay, we can now bootstrap intelligence with basically human intelligence, which is what foundation models really are. But maybe if we didn't do that and we just let the models learn from data and experience, so the Sutton way, we could come up with very different types of intelligence. And the analogy is always the same. It's the airplane versus the bird, right? The airplane does not have bird type flying experience, but it's obviously a lot better for certain tasks, maybe not as good for other tasks. And what we're trying to achieve here is what we're trying to get here is, of course, at Orange Capital Partners is not necessarily the best possible intelligence, but it's, of course, the intelligence that gets us the quickest to scale commercialization, because that's where we make our money. And therefore, maybe some foundation models could be useful here. And I think that's something that, for example, Tesla is working on with Grok and Optimus. So we believe that this is going to happen on the Tesla front. Also, the NVIDIA front is in. So it looks like the space is moving towards having spatial intelligence augmented with foundation models. Now, this, if we take Tesla FSD, which again, in our opinion, is the only real functioning at scale, customer-driven spatial AI. Now, FSD really has spatial intelligence. It knows that a car in front is not a car in the back, and that it cannot just drive through the car or whatever. I mean, it knows these things, right? I mean, anybody who's used FSD will attest that there is spatial intelligence here. The car is navigating around. I don't care. The pushbacks are, oh, driving is easy. The roads are structured. Well, most of the world is structured. The world is structured. When I walk through a forest, there's structure there too. There's not that many paths I can take. There's, I can't go up a tree. I can't go into the, in the world is actually a lot more structured than you might think. Maybe not as much as roads, but the world is structured. So I'm not so sure that FSD is a bad example for spatial intelligence just because it's supposedly easy or something. And by the way, a few years ago, it wasn't considered easy. And now all of a sudden it's easy just because it's solved. So there's a bit of that too. But anyway, my point is this: the question I have, and I asked that question already with Ramjan Krishna and many other questions, many other people that I met at CVPR. Okay, you want a spatial intelligence, you want to train robots specifically with spatial intelligence. But what if you just did the robot pipeline that we suggest, which is trained from video at scale and then fine tune? And the fine tuning on the mid training front is you can use maybe correctness approaches like Aviral Kumar and Sergey Levin's approach. So let the robot figure out tasks in reinforcement learning on its own, but give it a foundation with video-driven data, and then you can augment the robot with. You can potentially augment the robot with some foundation model intelligence. That at least in the short run, that's not such a bad idea. So the Tesla FSD is told, look, you're dropping me at school here. When you drop me at school every Monday, you can't park here. You should park over there. Like those kind of things. Now, last thing I want to talk about is sort of the way a little bit longer in the future. More maybe on the science front. Again, like our goal at Orange Capital Partners is time to market. That is what we want to minimize here, because time to market and market being scalable, commercial product, that means wealth for us, and we're in the business of wealth creation. But on the scientific front, I think there is an interesting concept where we would say that fundamentally, we're in the camp with Carl Schwager, which is most of intelligence is just memorization. Intelligence is lookup tables. The problem is we don't have unlimited compute and unlimited memory. So there's two fundamental questions here. If we want to approach the world through, okay, let's just memorize everything and then learn by combining what we learned in some reinforcement learning structure, which in the embodied world, of course, is much more difficult than in the language world because the dimensions are so much bigger. But let's assume we solve that problem by just solving the compute problem and solving the energy problem. So we have, let's say, AI data centers in space. We have abundant energy and abundant compute, and also abundant memory. And that brings me also to Andrew Davison's presentation, that we should be thinking about hardware also. We should be thinking about hardware because we could, in principle, have a graph structured memory that allows for this task-driven approach in a graph way. So we have, again, we memorized a gigantic amount of information, and now we can at inference time quickly assess which part of the memory is necessary for the task. So I think this approach, it's still a bit nebulous, but it makes sense. I think these vectors are coming together. So we have data driven, we have memory, we have a new type of hardware architecture that allows for massive amounts of memory, but not at inference time everything at the same time. So we have some sort of neuromorphic approach where we know, or we filter the necessary memory from the actual scene. So we sort of trigger, if you will, inference just means triggering the right context by which we can then tap our knowledge base and then execute. So that's kind of the way we see this going. So I think to summarize, Luca Carlone's presentation is very inspirational. It's not exactly on our path, but I think we should take particularly people like him very seriously, because he's created new fields with his work, and he might be maybe an older generation, and he might be a sort of a pre-ImageNet, foundation model generation. So in that sense, maybe he's a little bit, not outdated, that would be too harsh of a word, but he could be a little bit behind the eight ball, if you will. But he brings very interesting knowledge and very deep knowledge and very important knowledge to to the table. And I think that is the biggest lesson here, that we should take it and then, digest it with what's out there. And then fundamentally, of course, look at what is scalable and commercializable, because that's what really matters, at least for us here on Scalable Park.